Okay, now let us see with a 555 timer circuit for the lab purpose, right? So here, the 555 timer is nothing but an IC which is used to generate a pulse wave. That's which is used to generate a pulse wave, right? So we have totally two circuits in 555 timer. One is called as astable multivibrator and another is monostable multivibrator, right? So astable multivibrator, it generates continuous train of pulses, okay, and monostable multivibrator, it generates only single pulse. That is like the pulse what you people will give on the digital trainer kit, only one pulse, that is your monostable. And in the digital IC trainer kit, if you give the clock to 1 hertz, 10 hertz, 100 hertz, 1 kilohertz, then that is your astable multivibrator, right? So both the applications are available in your digital trainer kit, that is astable multivibrator and monostable multivibrator, right? So hence for the syllabus of the lab purpose, so we have a 555 IC as an astable multivibrator, right? So astable multivibrator, it is like, it is the kind of circuit which generates continuous train of pulses, right? So which generates continuous train of pulses. Okay, so continuous train of pulses. So in order to go with this 555 timer, so this 555 timer IC is of around 8 pin, right? So is of around 8 pin. So where the IC pins are like this. I will explain the IC pins. Okay. Okay, so as you can able to see on the screen, so we have an 555 IC timer, so which is of around 8 pin, where pin number 1 will be connected directly to ground. Pin number 2 is called as trigger, right? So which will use to trigger the signal for monostable multivibrator, right? So it will trigger the op amp which is available inside the 555 timer. And pin number 3 is your output pin. Pin number 4 is a reset. So by using high signal or by using low signal to this reset pin, the entire waveform can be made into zero. And pin number 5 is a control, and pin number 6 is threshold, where pin number 5 will act as a control. It says that in order to have one, there is logic 1 and logic 0. So as I said, it generates a pulse wave. As I said, it generates a pulse wave. So in order to decide till what level, if it is, say for example, 0, it means that 0 volts, and 1, it means that plus 5 volts, right? So what happens if I receive an output signal which is of around 4.7 volts, or what happens a signal if I receive it as 0.3 volts, right? Hence the neutralization has to be considered, and from 4.7 it has to be made to 5, and from zero point 0.3 it has made to 0, right? So because 0 will be the nearby value if I get 0.3 volts, and 4.7 the nearby value will be 5. So I need to match to that particular value. So that providing that part, it will be depend upon this threshold pin. Okay, and pin number 7 is what discharge, where the capacitor will charge from the pin number 2, and it will start discharging through pin number 7, right? So trigger means the capacitor will be triggered to charge, that is pin number 2, and pin number 7 is discharge. So it means that pin number 7, the capacitor will start discharging via pin number 7, and 8 pin will be our VCC. Okay, so this is the pin out of 555 timer, right? So this is a pin out of 555 timer. So meanwhile, I have got a circuit for 555 timer, so as an astable multivibrator, right? So in this part, so astable multivibrator, so pin number 8 and pin number 4, which is nothing but VCC and reset, are shorted and they are connected to VCC, right? So they are connected to VCC. Here VCC I need to provide as 12 volts, right? So 12 volts, 9 volts, 5 volts is also possible, right? And I need to, in order to design for the astable multivibrator, as per the design procedure, that is, I think the equation will be 0.6 0.6923 into RA plus RB into C, that is your T on, and T off is equal to 0.693 into RA into C. Okay, so this will be the two equations which will be used to find out the value of the resistance RA and RB, right? And we need to assume the capacitance value as zero point 0.1 microfarad, which is connected between pin number 2 to ground. And the pin number 5, which is supposed to be acting as a control pin, it has also connected with one more supporting capacitor, and that supporting capacitor value will be equal to 0.01 microfarad, right? So please do remember the I capacitor which is connected at pin number 5 is 0.01 microfarad, and the capacitor which is connected between pin number 2 to ground, it is zero point 0.1 microfarad, right? So in the slide, left side capacitor is your zero point 0.1 microfarad and right side capacitor is your 0.01 microfarad, right? So the combination of RA, RB and C, RA, RB and C, and here you can check it as C dash. Okay, so the capacitor which is connected at pin number 5 is C dash, and the capacitor which is connected at 2 and ground is called as C. Okay, so hence the circuit element RA, RB and C, it decides the way of the duty cycle required, right? So whether it is 50%, then RA and RB both should be same. If it is greater than 50%, then maybe RA is greater than RB. Then if I need to have a duty cycle less than 50%, then RA should be less than RB. That combination we can able to calculate with the help of the equation called as T on is equal to 0.693 into RA plus RB into C. That is one equation. And to calculate T off, which will be equal to 0.693 into RA into B. Sorry, RB into C. That is a second equation. Okay, so hence the same circuit, in order to design in the software, I have a version of the software called as electronic workbench, right? So now, what are the things I need to have as per the circuit diagram? I need to have 555 IC, right? So where is that particular 555 IC? You have to search it out in the working window of the electronic workbench software, which is nothing a kind of PSpice or a kind of KiCad software, and I can able to see that in the mixed IC. In the mixed ICs, I have one IC which is supposed to be called as 555 timer, right? So I will drag that 555 timer to the working environment so that 555 timer as per the pin diagram it will be available, right? So as per the pin diagram it will be available, right? So I will try to zoom out. I will try to zoom in. Means change it. So I think this is visible now. So the 555 timer, as soon as I place, as per the pin diagram, the 555 timer has been placed here, right? So ground is pin number 1, 2 is pin number trigger, 3 is output pin, 4 is reset pin, 5 is control pin, 6 is threshold, 7 is discharge, and 8 is VCC. Right? Now, after to this, what else I need to have? So I need to have one VCC. VCC nothing but 12 volts DC power supply. So I will go to the sources and I will take DC supply which is of around 12 volts, right? The purpose of this is, if I take this, then I can able to give any voltage here. And there is one more thing supposed to be called as VCC. If I provide this VCC, then it will be a constant voltage, right? So this also you can able to put it, or this also you can able to put it, right? So no need to worry about this like the image which you can able to see it on the working window, because it doesn't matters with the graphic, because there is a need of a graphic card for this, but because of no availability of the graphics card, it might show like this. Okay, so now you can use any one. So better for me, I will use the regulated power supply, which is a DC power supply like this, right? So hence, in the similar way, it can be rotated to any style. Okay, it can be rotated to any style. So I will take this. So I will take this and I'll keep it over here, right? Now, as per the circuit diagram, check out the circuit diagram. As per the circuit diagram, pin number 8 and pin number 4 should be shorted and it has to reach for VCC, right? So here also I will do, this is your pin number 8. Pin number 8, if I go to the corner of the VCC, I will get a notch. So from that notch, I need to click and I need to drag the mouse pointer without leaving the mouse pointer, and I need to connect it to the VCC. Okay, so this is how I have connected pin number 8, right? So now I have one more pin to be connected to the VCC, that is your pin number 4, right? So pin number 4 is your reset. So I will try to connect directly to the VCC with the interconnection of this one. Okay, so these two things, it will show us the connection of pin number 8 and pin number 4 to the VCC. Correct. Next, continuation with the circuit. So we have one resistor which is found to be RA, and it has to be connected to pin number 7 and pin number 6. Okay, so the value of the resistor with the help of the design procedure with the equation 0.693 into RA plus RB into C, and that is T on equation, and T off equation will be equal to 0.693 into RB into C. Okay, so hence I need to have two resistor. So I will go to the panel and I will select two resistor in the panel called as basics, right? In the basics I have resistor, so I will take two in numbers, hence in the circuit there are two resistors to be connected. Okay, so these are the two resistor, so I will rotate it and I will make it as a kind of requirement for our particular circuit, right? So do one thing, I will bring it out here. Okay, so do one thing, I'll bring it out here, and also with respect to this. Okay, and also with respect to this. Okay, so this is what I'll bring it out here, right? And similarly this is also I'll bring it out here. Okay, so these are the things. Now uh, I need to connect, see, as per the circuit diagram, once placing the resistor, one end of the resistor I will treat it as RA and RB. One end of the resistor RA should be connected to VCC, right? So this is RA and RB. If I treat this as RA and RB, then one end of the resistor it has to be connected to VCC. Okay, so this is what VCC. I will click here and I will drag that so that it will be connected to VCC, right? Why? Because you can able to see that this is the pin which is connected to VCC over there, right? So if you select on that pin, it will show the highlighted one, so you can able to see that it is connected to VCC, right? Next, there is an interconnection between one end of the RA resistor with another end of the RB resistor. Okay, so I will connect these two part over here, so that as per the circuit diagram, this is what the connection. So next, to that intersection of RA resistor one terminal and RB resistor one terminal, there is a connection which goes to pin number 7. Okay, so this is my pin number 7, right? So from this pin number 7, the interconnection between these two has to be connected. Okay, so next, that is your pin number 8 and pin number 7, right? So now let us see what happens to the pin number 6. Okay, so to the pin number 6, pin number 2 should be shorted, and either from the pin number 6 or from the pin number 2 it will reach to the other end of the resistance RB, right? So what I will do from pin number 6, okay, so from pin number 6 I will try and I will connect it to the other end of the resistor, and meanwhile I will take this pin number 2. Okay, I will take this pin number 2 and I will connect it to pin number 6. Okay, so this is what your interconnection of your IC, interconnection between pin number 2 and pin number 6, and it has been reached to the resistor other end. Okay, so register other end, right? So this is the connection which will be available. Now after the continuation, after the continuation of RB resistor, like this connection is completed now, then the other end of the RB resistor should again consist of one capacitor. So for me there is requirement of two capacitor, so I will go to the basics and I will take two capacitors, right? So in the basics panel or in the basic palette, so I have a capacitor, right? So I will, how many resistance I need to take totally, sorry, how many capacitance I need to take totally? Two capacitors. Okay, I need to take totally two capacitors. Okay, so now see, I will rotate this capacitor so that it will look as similar to that of my uh, circuit diagram. So this end I will connect it to another end of the capacitor. Okay, so I am trying to check out with the same connection, so that it will be same connection as that of your circuit diagram, right? So this is what I will connect it, one end of the capacitor, right? And what is the other end of the capacitor? Other end of the capacitor, this is what I have connected. Other end of the capacitor should reach to the ground. Okay, so it should reach to the ground. So what I do, I need to have a ground, the common ground. So I will take this common ground over here, right? And the another end of the capacitor, it should go and connect to the ground line. Okay, so that is the connection which is available for this part. Similarly, pin number 1 should be directly grounded. So here it is your pin number 1, so I will just take it and I will directly connect it to ground. Okay, so next, left out is only pin number 5. That's a left out is only pin number 5. So that pin number 5, I will connect it in such a way that it should reach to the capacitor positive terminal, and the other capacitor terminal should reach to the ground. Okay, so this is your entire connection, right? So now the some entire circuit is what completely connected as per the given circuit diagram. And what is pin number 3? Pin number 3 of IC555 is output, right? So here I need to connect the CRO, that is cathode ray oscilloscope, in order to check the pulse waveform. It's in order to check the pulse waveform, right? Hence, very first and foremost thing, there is one more terminal is left out, and that terminal is the other end of the power supply, because it is like blank, it has left as blank empty. So it is mandatory for me to connect a ground here, right? So you can drag the connection to the ground. Okay, so you can drag the connection to the ground like this. Okay, or you can able to give one ground connection from the terminal, right? See, this is connected with the ground now. So the first term, the positive, this I think DC power supply or DC supply, the diagram you people know that. So which has got the bigger dimension length, that is called as positive, and which has got the smaller dimension length, that is called as negative, right? So hence positive I have connected as plus VCC to pin number 8 and pin number 4, and similarly negative I need to connect it to the ground, right? So if I double click on this power supply, then I will get a panel, and this panel will provide me the voltage and voltage tolerance, right? So here you can change the voltage. If you want, you can put it 9 volts. If you want, you can put it 12 volts. Even though if you want, you can put it 5 volts. Whichever VCC you have practiced in the lab, you can able to provide that as 12 volts, right? Say for example, can I know what is the value of the capacitor, sorry, resistance you people have used in the laboratory for 50%? What's the value of the resistance you people have used for 50% duty cycle for the Gulf timer Astable multivibrator?
Both are 3.6 kilo.
Correct, right? So hence, when I reach to the resistor, double click on that resistor, then here is a panel where I can able to change the value of the capacitor as per the required design. Okay, so as per the required design, the resistance value is what found to be 3.6 kilo ohm. So I can directly take 3.6 kilo ohm, right? So here, I will just mention you the advantage of using software than that of the hardware circuits. Like say in the previous designs, you may design or you may calculate the value as 4.7k, right? Or maybe 5.3k, you will get a value of the resistance as 5.3k. But when you want to do the circuit connection, you will not get exactly 5.3k. You will end up with connecting 4.7k or connecting 6k, right? Hence, in the software, however the design value is obtained, however the component value has been obtained, I can change it. Right? Say, for example, after solving for R and RB, if I get 3.65 kilo ohm, then directly 3.65 kilo ohm, I can type it in the software, so that it will just accept the value as 3.65 kilo ohms itself. Okay, right. And based on that, the capacitor which is connected after the two voltage divider resistor, this value is what found to be zero point 0.1 microfarad. So I will change that thing to zero point 0.1 microfarad, so that it will be available with the concerned value, right? There was one more capacitor which is connected between control pin, that is pin number 5 to ground, and the value of this capacitor is what found to be 0.01 microfarad, right? So there is a knob given here, right? So sorry, the software will not get maximized, or it cannot be magnified here. So in the range, so here we have got microfarad, picofarad, nanofarad and all. So when in the laboratory I have used 0.01 microfarad, so I will use the same thing as 0.01 microfarad, right? So now the entire circuit connection, it's been done now, right? So now I need to check out with the output voltage, right? So in order to check out with the output voltage as in the laboratory, so you have used the CRO. So here in the circuit, in the software also, we have got a CRO, and that CRO is available in the instruments. Okay, so in the panel called as instrument palette. Okay, so click on that instrumental palette, right? So then it will be available with a number of devices like multimeter, function generator, oscilloscope, right? So CRO stands for cathode ray oscilloscope. Hence, it's better for me to take out the oscilloscope, right? So click here and drag it out, so that it will be available with one box which is supposed to be called as an oscilloscope, right? So which is supposed to be called as an oscilloscope, right? So as in the oscilloscope, I think everyone has seen the oscilloscope in the laboratory. So we have two channels, channel 1 and channel 2. In the similar way, In this panel also have got two channels, right? So the bottom two connections are supposed to be called as channel 1, and the side connections to what we have, that is supposed to be called as channel 2, right? Or you can treat this as channel 2 and this as channel 1, right? Say for example, I will connect the channel 1 positive to output pin, that is pin number 3 is your output. So I will connect the channel 1 positive pin to the output port, right? So here, as you can able to see that in the software, if I go near to any of the knobs, it will not show it as positive and then negative. So it is your duty that however you want, you can connect it, right? So whether you can connect this pin to output and this pin to ground is also possible. Connecting this pin to output and this pin to ground is also possible, right? So only one pin should go to the output, right? Now, pin number 3 have connected to the output, and that output is connected via CRO. Similarly, what about another pin? It is mandatory to connect the another pin to the ground, right? So this is your ground. So I will just connect a common ground for this. So this will be connected to the ground. Okay, so this will be connected to the ground. Okay, so wherever the notch is there, you have to cross check out with this, right? Now, this is your entire connection. So now you need to activate the electronic circuit. I need to activate this circuit in order to see the square waveform, which is found to be an astable multivibrator, right? So before activating the circuit, let me open the panel of the CRO so that people can analyze that this is the same thing as you people have seen in your CRO in during your physical labs, right? So in the physical labs, in the CRO, we have called as channel 1 and channel 2, right? So channel 1 and channel 2, but here I have channel A and channel B, right? So this part is what's supposed to be called as channel A, so that is left hand side, and this part is what's supposed to be called as channel 2, right? So as you have channel A, channel 1 and channel 2, two variations in the CRO. Similarly, here also you have two variations in the CRO, and you have only one TB, that is one time-based knob in CRO physically. Similarly, in this panel also, we have got only one time per base panel, right? So in order to change the value, you have to use the drop-down button structure in order to change the values of time base and in order to change the value for voltage per divisions, right? Now, anyhow, I have connected. Still, if you want, you can expand the CRO so that you can able to view it in a bigger, larger way, right? So here also it is same time base. I think it is visible if you zoom out your screen resolution. The first one is what your time base, which is now set at 0.50 seconds per division. Trigger, don't worry about trigger, and there are totally two channels. One is channel A and another is channel B, right? So in the channel A, the volt per division knob is set to 2 volts, and in the channel B, the volt per division knob is set to 5 volts, right? So hence, as you people have already connected the CRO to output pin and CRO other terminal to ground, now it is your duty to execute the project, to execute the circuit, right? So at the right hand corner, at the right hand top corner, so we have a switch called as active simulation. Let's say we have a switch called as activate simulation. So click on that activate simulation, the waveform started to generate, right? Hence it is found to be very thick because the time per divisions is in seconds. This time per divisions is in seconds. Now I need to make it to bring to kilohertz, right? So in order to make it to bring to kilohertz, so the time per division from the seconds, it has to reach to milliseconds. So if time is in millisecond, then I will get the frequency in kilohertz. Okay. So I will try to change this one. So that is 0.20 seconds, 0.10 seconds, 0.5 seconds. Okay, the signal started to come, right? So by keep on changing the time per divisions, now see it is 5 millisecond, now it is 2 millisecond. Okay, so now it is 1 millisecond, right? So I'll just set it for 2 millisecond, and I will increase the range of this one. Okay, so there is channel 1 I have connected, right? So channel 1 I have connected. So this is what your this is what the connection of your CRO, right? So I will try to get the result now. I will make it view it possible now, right? So where it is, I think expand. Okay, expand version. Okay, so activate. Just a sec. I will just. I tried changing something. Okay, so this is your cable phi timer. Open this up. Okay, and you can use the activation button. So I'm just checking out with a reduced version. Where is reduce? Okay, reduce. Let it be in a reduced version. Okay, so I think this looks better now. Okay, so this looks better now. So activate it. So then you can able to find you can able to find the CRO with providing the pulse which is of around 50% duty cycle. Okay, so which is of around 50% duty cycle. Okay, right. So I think I need to like if you start analyzing this circuit, so then you will come to know so how the signals are generated, right? So hopefully the signals are visible for you now. It is supposed to be called as kind of pulse wave, right? So supposed to be called the kind of pulse wave, right? So I will try to increase the width of the pulse. Okay, see, I think it is, you have to be in a position so that there was something thing called as stop. I don't know where it is, that stop button. Okay, pause button was there, but I forgot that where is that pause button. So meanwhile I will let you know, right? So hence, by changing the time period, so you can able to get the waveform in a more beautiful way, right? So I think this is visible now for you people. So this is your sine, this is your square wave, right? So this signal is enough, right? So hence, the another one was there which is supposed to be called as capacitor output, correct? So there is another one which is supposed to be called as capacitor output. Hence that capacitor output will gives you the charging and discharging time, right? So anyhow, there is channel 2 as we connected in the lab, channel 1 and channel 2. So meanwhile, I will also connect channel 2 to capacitor, right? So this signal, I will connect it to the capacitor. Across capacitor means one terminal should go to the positive end of the capacitor and another terminal, it will reach to the ground, right? So it will reach to the ground, right? So ground, anyhow, the ground is here. I will connect the ground here, right? So now see, the circuit is still in activating condition. So if I just open the clock, then for the safer side, first I will remove this output signal and I will try to check out with only capacitor output, right? So I have removed the output signal and I have connected only the capacitor output. So I'll just activate the signal, right? So I'll just activate the signal so that I think, okay, so it has to be available with the capacitor charging and discharging time. Okay, so pin number 3. Okay, so this is your capacitor charging and then discharging provided. It will be provided like this, right? So anyhow, there will be a small like kind of software. Because of the software, so we have certain things, certain issues to be checked it out. But only if you get that positive pulse, then that is okay, enough, right? So you can show this as the charging and then discharging of the capacitor, right? So it is not as accurate as our hardware, but it provides some kind of simulated part, right? So hence, this is how you can able to generate one set of the signal, right? So this is how you can able to generate one set of the signal. Okay, right? So hence, for us, instead of capacitor output, so it is better to have the main output. So I will connect this main output and I will connect this to ground. So this will make me to generate the pulses. Okay, see, the pulses are there. Okay, so I think you people can able to see the pulses. Okay, see, this is what the exact pulse. I have stopped at exact pulse by using a pause button, which is there at the right corner. Okay, so this is your pulse wave, right? Pulse wave, if you get it, then that will be enough, right? So now, in the similar way, you can turn off the activation. Let's say you can turn off the activation, and if you want, you can change the value of the resistance now. So, for example, I will change this resistance value to 7.2 kilo ohm, and I will keep the other resistor as 3.6 itself, right? So now, let us see what happens to the circuit, right? So I think I will pause the signal. Okay, so I'll just try to pause the signal at exact intervals of time. Okay, see, now is it clear? Now you can able to view it very clearly that T on is more than T off, right? This is the width of the T on and this is the width of the T off. So this indicates that I have designed the circuit for more than 50% duty cycle, right? Now with a very simple way, again what I will do, I will make this as 3.6 kilo ohm, right? And I will make the other resistance as 7.2 kilo ohm so that it will generate the duty cycle of less than 50%. Okay, now see, open the panel and release the pause. Click on activate once again. Okay, right. See, now I think the value of the resistor should be again still more increased. Okay, right. So now this will provide the another set of the waveform. I think I need to match with the resistance value, then only it will happen, right? So I will do one thing. I'll just make this as 1 kilo, right? So this is a trial and error method. So if you want, you can do any changes because you will get the exact value of capacitor and exact value of the resistor. Okay, now I think probably still it has got bit equivalent symbol, that is 1 kilo ohm and 10 kilo ohm, right? So hence there are bit of like of deviation with respect to the hardware circuit and with respect to the software. But this is how you people can able to execute one simple experiment of 355 timer using electronic workbench. Correct? So is that clear with this? So now the next of the experiment will be explained to you in the next class. So I will pause the recording, and so that if there are any doubts and if there are any queries, you people can ask. Okay, the recording has been stopped, so that if there are any queries, then you can ask it regarding this electronic workbench. So actually this is electronic workbench. The same thing you have to design it using P2 Spice, and that P2 Spice or P Spice I will tell you in the next class, right? So in the next hour class. Is that clear with this? Right. Any doubts? I've stopped the recording so you people can talk.
No, sir.
Okay, now see, just for a small case, as you people have executed some blinking program yesterday in the workshop, so what I did, I just removed the entire CRO. Now, instead of CRO, I will put an LED. Okay, so there is a panel for LED. So I will just click on that by indicators in that
That screen
indicators.
is not shared.
Sorry?
Screen is not shared, sir.
Okay, sure. Sorry with that. Earlier thing, it was shared, no screen.
Yeah, sir. When you stop the recording, you just.
Okay, I think it's went out. Okay, I'll just reshare it once again. Okay, see, I think now it's visible. See, I have just removed the output part. I just removed the output CRO, and now the pin number 3 is free, right? Now, instead of this CRO, I will connect one LED. So this LED is supposed to be called as red probe, and it is available in indicators. It's available in indicators. If you click on that red LED, it will be available here, right? So it has got only one terminal. Luckily, there are few manipulation, one terminal. So if I connect this to the output, okay, this to the output, and if I just activate it, then see, is it blinking? Yes, it's blinking, right? So if I change this to 3.6 kilo, sorry, this to 7.2 kilo ohm, okay, and this to 1 kilo ohm, this to, sorry, 2 kilo ohm, I'll just check it out with like this 2 kilo ohm, then see again I will activate, see again you can able to see a small difference in blinking of this part, right? So similarly, if I want to change it to 72 kilo ohm, you can see that what happens to the circuit in that 72 kilo ohms. Clear? The blinking time, it keeps on changing. This blinking time, it depends upon the duty cycle. Okay, so all this kind of experiment with a very minute changes, with a very minute changes, you can able to provide it, right? So not only one LED, not only one red probe, you can place n number of red probe, and you can connect it with the circuit, so that now see, two things are connected, right? So how much ever you want, you can able to drag it out, and you can able to check as a kind of application. Okay, so this is how your circuit looks like when it comes to the application, right? So I think so you people have seen the blinking light everywhere, blinking light with some kind of display. Like if I want to display my name on an LCD, on an LED panel, which consists of which consists of 100 LEDs, and only my name has to be displayed like PRADEEP, only with respect to the activating to those LEDs with a 555 timer, I can make it as a blinking light, right? So this is what one of the application of our Astable multivibrator, right? So now only instead of CRO, I have changed to LED. That's it. If you want, you can connect CRO to take out the tracing of that one, right? So by with a plug and play concept, that is with a simple trial and error method, you can change the value of any resistance, and you can able to check the connection and design the connection and check the output waveform. Clear? Right. So that's it for today's class regarding 555 timer simulation version or the software version. Right. So hopefully, I think the drive link for EWB, I have shared it in the very beginning class during your bridge courses. So please kindly circulate it, recirculate it once again to the group, so that others can able to download it, install it. I think it will be easy for installation. Okay. So and then start using this one as a kind of experiment or a kind of example circuits to know the input and output over there. Okay, so any issues, any queries with this circuit? So 21 members are there. I think morning attendance have given here. Any of it's been okay. So who is Mr. Hunter? Who is Mr. Hunter? Is it audible?
Yes, sir. It is audible.
Is it Rohit? I think Rohit has still got no college email ID. I think it might be him. Okay, Zeba, Vinayaka, Usha, Tanushree, Suman, Sumadva, Srushti, Chandana, Shyam Pandey, Shubha, Shreyas, Sharan, Sevanti, Sanidhi, Sai, Shushma, Ritushri, Dhanush. Okay, so 20 members are there. I can remember the attendance and I will provide the attendance for that one, right? So hopefully, I guess the last person is Rohit, it seems, right? So that is your attendance, right? So any other queries, then please do ask it out, or else we'll end the meeting for today regarding 555 timer simulation version.
Excuse me, sir.
Yes.
So I'm yours. I mistakenly logged in with another account.
Sorry, who is that? Come again?
Sir, I'm yours, sir. I am
Okay, our okay, no problem. You listen. No, that's what I thought. That I attendance for attendance. I just asked it. Okay.
all right, sir. All right.
Okay, right. So no issues. If you're logging with a personal account or if you're logging with a college account, that doesn't matter. It's only the content what you listen that matters a lot. Okay.
All right, sir. Thank
Yes. Okay. Yes. If there are no queries, then shall I end the class? Dhanush, any queries?
No, sir. Not at all.
Okay. So then I will end the class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.